Hello, so I'm going to go through everything that you need for your IGCSE probability. So all things probability for the exam so you're really well prepared. So the first thing we're going to look at is a typical paper 2 question, which is based on relative frequency. And if you don't know that phrase, you really do need to know it for your IGCSE exams. So let me go through 2 examples with you where we test your knowledge of relative frequency and whether you can multiply and work with fractions and decimals.
Okay, question 6. So a biased four-sided spinner is spun 150 times and we're given a relative frequency table. Okay, this is a term that students often forget what this means. So relative frequency basically means the same as experimental probability. It's another phrase for the same thing. If I wrote it like this, it makes it more straightforward what we have to do. So the relative frequency of a spinner landing on 2 is we take the frequency of landing on 2, which is 63, and then we divide by how many times the spinner is spun, which is 150. And since it's a 1-mark question, I don't think we need to simplify. I'll verify that. Yep, we don't need to simplify, although I think it doesn't simplify anyway. Again, 1-mark question, you don't need to worry too much about working. Obviously 2 or more, then you do. Explain why it's reasonable to use your answer as part A as the probability of this spinner landing on 2. Well, notice we spun this 150 times, so we've got a large sample size. They often ask a question like this on IGCSE. If this was only like 20 times, for example, it wouldn't be such a reliable probability. So all we need to do here is just write large sample size or spun many times or something along those lines. Okay, and at this point, we've got the spinner is then spun 3,000 times. That's quite many spins. I wouldn't recommend this at home. And then find the expected number of times that the spinner lands on 2. So expected 2, use this notation a lot at IB. The way we do this is we take our previous probability, so 63 over 150, and then we multiply it by the number of times that we spin. So what they've done with this question is they've integrated a bit of working with fractions here as well, because we actually have to now work this out without a calculator. Now, if I was to ask you this question, so say 1 over 150 times 300, you would probably see at this point that this goes into 300 twice, and this would cancel down to 2. So using the same idea, instead of 300, we have 3,000. So all we need to do is add an extra 0 on. So 150 goes into 3,000 20 times. This will make your life a lot easier to solve this. So essentially what they want us to do here is work out this particular calculation, which is 63 times 20. The way I would do this, I would rewrite this as 630 times 2. We can do this with multiplication. It's commutative. You can move the 0 around, so to speak. And then all we have to do is double this to give us our answer. So if I was in the exam, I would do this old school. I would actually write this out. 0 times 2 is 0, 3 times 2 is 6, 6 times 2 is 12. And I get to my answer of 1,260. Okay, I'm not doing anything too clever. I'm just taking my time and going through this nice and logically. And you do have 45 minutes for this paper, which I think is fair more than anything else. Okay, that's a sip of coffee. Let's carry on. So we've got question 6 there. Mark scheme, of course. You get 1 method mark for the working I just wrote. Notice this OE, by the way, let me just point this out, is equal to or equivalent. Might be something you're unfamiliar with from the mark scheme. So that means as long as I write something that means the same, that will still give me the method mark here, for example. I'm not sure what else I could write, but if I did, and it's the same as this calculation, you get the M1 mark. This kind of question. It's in the title, actually. You can see it right there. This is called a relative frequency question. So if you want to do more work on this, this is under relative frequency, which is probably under the probability section of any course that you are doing. Don't forget the I. Like so. So Jamil has a biased 6-sided die, that's a dice, He rolls it 350 times and the results are shown in the table. How many times he's getting each thing on the dice. And you want to find the relative frequency of getting a 2 with Jamil's dice or die. So the way we do that, well, we take the number that we're given, so you've got 50 of the 2s, and we divide it by the total number of times he rolled the dice, which is in the question, 350 times, and then you can simplify that, so 50 divided by 350. I don't know if you have to simplify for the mark scheme, but you should get 1/7. So let me just check that. Question 11a. You should always check the mark scheme as you're going along to make sure you're doing everything right. Yep, it accepts 50 over 350 or equivalent. That's what the OE stands for. And there's your answer as well. Explain why your answer in part A is a good estimate of the probability of getting a 2. Well, you rolled it 350 times. So you can put, like the mark scheme did, big sample size. I would say large number of trials. That would be my answer. Anything that indicates that he's rolled it a lot of times. And you're usually quite flexible how you explain that. Yeah, large sample or equivalent. So anything that means the same idea. Okay, and estimate the number of times Jamil will get a 2 if he rolls the die 1,400 times. The way we do that is we take the relative frequency from part A, so that is 1 divided by 7, and then we multiply by the number of trials we want to do, which is 1,400, which on the surface looks like quite a tricky question, but remember, fractions of amounts, divide by the bottom times by the top, so this is equivalent to 1,400 divided by 7, which comes out very nicely at 200. So you expect it 200 times to roll a 2. Considering the probability is 1/7, that makes kind of sense. So that's quite a nice probability question to get on the exam. I certainly wouldn't be too unhappy if I saw a question like that.
But sometimes on paper 2, they also like to push your understanding of working with a tree diagram where a tree diagram isn't necessary, but they want you to work out a situation of a repeated probability. You're going to see this in the next question.
Okay, now this is harder than it looks on the surface because it's not clear about replacement. A factory makes soft centre chocolates and hard centre chocolates only. The probability that a chocolate chosen at random has a hard centre is 0.6. 3 chocolates are chosen at random. Find the probability they are all soft centre chocolates. Okay, so what we're looking for essentially is the probability of soft, soft, soft. Okay, that's essentially what we're looking for. Okay, so the problem from this question is not clear whether there's replacement or not. Now, you have to take it from context. It's a factory, so they can have many millions of chocolates being produced at any one time, many thousands of chocolates at any one time. There's no information to tell you it has not been replaced, if that makes sense. So if you assumed it hasn't been replaced, we don't know how that changes the probability. We're not told. Therefore, you have to assume it is replaced, which is probably the most confusing thing about the question. So if we go back to what we're doing here, the probability of a soft chocolate, well, if the probability of a hard chocolate is 0.6, the probability of soft must be 0.4. because the factory only makes soft and hard centre chocolates. Now we want to work out the probability of soft and soft and soft. Remember, and in probability means multiply. So you need to take the 0.4 and then we multiply. Come on, 4, there we are. 0.4 and then we multiply by 0.4 again. And that's all there is to it for the answer. The trickiest part now is just to work out exactly what this is. Well, we have 3 decimal places in the question, so we need 3 in the answer. Now, you should know that 4 times 4 times 4, well, 4 times 4 is 16, 16 times 4 is 64, so we know that's in the question. And therefore, we need an extra 0 here, so there's 3 decimal places in the answer. 1, 2, 3, 1, 2, 3. And we know we've got the right answer. There, unfortunately, is replacement in this, even though it's not obvious from the question that there is. And also, the amount of marks they give you is a bit confusing. You'd expect to do more maths to get those 3 marks. So, yeah, not a very nice question. There's the answer, 0.064. I imagine the mark scheme will say something similar to what I said. Okay, most people realise how to cube 0.4 and struggle to work that out. And significant number of candidates who thought there was without replacement and tried to calculate this. I do have sympathy for that. It didn't seem obvious at all that you'd have to not do replacement. So I do have sympathy for those candidates, and it wasn't obvious from the wording of the question.
And now let's look at paper 4 questions. So we're going to start here with a sample space diagram. And it's a really useful way of working out a lot of different questions, and you're going to see exactly that on this paper 4 question.
So we've got spinner A, number 2, 3, 4, 5, 6, 7. Spinner B, 2, 3, 4, 5. And each spinner is equally likely to stop on any of its numbers, and each spun once, and the number that each spinner stops on is recorded. So standard question. Find the probability that spinner A stops on a number less than 4. Remember, less than 4 doesn't include 4, it's just anything less than 4. So if we take our spinner A, the only numbers here less than 4 are 2 and 3. So the answer here is going to be, well, we have 2 numbers out of how many in total? 1, 2, 3, 4, 5, 6. So we get our answer of 2 over 6. Now, you'll get all the 1 mark for this, but you should always get into the habit at least of simplifying your fractions. And this is the same as 1/3. On to question B. So spinner B stops on 6. And this seems confusing because if we look at spinner B, well, there is no 6 here. Yeah, there is only a 2, 3, 4, and a 5. Therefore, the probability of spinner B being on 6, well, that's impossible. And the way we express that in mathematics is we put a big 0 to indicate that it is impossible. Now, on to questions C, D, and E. For these kind of questions, one of the best ways of actually doing this kind of question is using what's called a sample space diagram. So whenever you have 2 spinners and you're spinning both spinners and looking for combined probabilities, a sample space is the way to go. Now, what is a sample space diagram? So let me show you this. So I'm going to draw out a big grid. So it's going to look like this. And we're going to put 1 spinner on the top. So we've got 2, 3, 4, 5, 6, 7. So that's going to be spinner A. And then spinner B is going to go on the left-hand side, and it doesn't matter which way round you do this. So as long as you get this kind of diagram. And all we do at this point is actually write in the different combinations we can get. So for example here, I'm just going to write in 2, 2. I'm going to write in 2, 3, 2, 4, 2, 5, and so on. Okay, so I'm just going to skip ahead and put all these in. And then once we've done that, then we can talk about how we're going to answer the following questions. And I cut out all that part so you didn't get to see me put in all the different values here. But you can see I've worked out every combination. So 3, 3, 3, 4. And of course the other way around, so 4, 3 as well. So now we've got this grid, we can then answer the 3 questions we have very easily. So the first question is, when do spinner A and spinner B both stop on the same number? So if I go to my diagram, and let's do this in blue, when they're on the same number, well, we've got 2, 2, 3, 3, 4, 4, and 5, 5. So the way we can answer this question is there are 4 possibilities out of all the possibilities that are given. So we have 4 possibilities, and this is out of, if you look at all these combinations, there are 24 in total, yeah, because we have 6 by 4. So the answer to this question, so I'm going to do this in red, is 4 out of 24, which would of course be valid for the 2 marks. My working would be the sample space diagram, but this is also equal to 1 over 6. Makes these questions much, much easier. Now, the next question is a bit trickier. So one number is prime and one number is not prime. So this is what we're looking for. So 1 prime, let me just write this over here, and 1 not prime. And the way I'm going to do this, I'm going to choose a different color here. So I'm going to choose green. So I'm going to go through and make sure there is 1 prime and 1 not prime. For example, the first one, they're both prime, so that doesn't work here. We have 2 primes here, 1 prime, not 1 prime, good, both prime, 1 prime, 1 not prime, these are both prime, both prime, both prime, 1 prime, not prime, both prime. And we go through this process, so I'm going to speed ahead and I'll get to the final answer. Okay, and so I've labelled all the ones are 1 prime and 1 not prime, or the other way around. So I've got 1, 2, 3, 4, 5, 6, 7, 9, 10 green. So I've got 10 green out of 24 in total. So let's go back and pop that in. So we have 10 out of 24. And again, this can be simplified for 5 over 12, like so. And even though this is a 3-mark question, the way we did this was very logical, okay? Using this diagram to help us with all 3 questions, and see we got the answer very, very easily. Now on to question 3. The sum of the numbers is a multiple of 3. So multiples of 3 would be things like 3, 6, 9, 12, and 15. I don't think we need to go to 15. And we want the sum. So the sum means you add them together, yeah? So add together. So I'm going to do a similar process. Let's get a different color out here. So let's use purple in this case. And what I'm going to do is go through and see if the sum is a multiple of 3. So for example, the first one, well, 2 plus 2 is equal to 4, not a multiple of 3. 2 plus 3 is 5, not a multiple of 3. 2 plus 4 is 6, well, that is a multiple of 3. 2 plus 5 is 7, it isn't, etc. 2 plus 7 is 9, that is a multiple of 3. So I'm going to go through this process and label in purple all the ones that are multiples of 3. Okay, so I've labelled everything here in purple, which is a multiple of 3. So we've got 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 out of 24 that are multiples of 3. And then we're just going to write in our answer. So 8 out of 24, and that's the same as 1 over 3 for the correct answer. So notice that sample space diagram has saved us a ton of time to work out C, D, and E, which actually add up to 3, 5, 7 marks. So this is a good investment of time, so you can read off the answer really, really easily. You can have a look at the answers here as well. They've done it in a kind of different way. In the top mark scheme, I've taken this approach down here. This approach is kind of the same for both questions. So I've used this idea of a table of outcomes. And notice this OE, if you're not familiar with this, means or equivalent, which means if you wrote the answer of 2 over 12, you'd still get all 2 marks.
And probably the most important topic on paper 4, and that is the use of a tree diagram, either conditional or unconditional. And you're going to see 2 questions now that actually go through this type of question. You really do need to have a good understanding of this to get those 10, 12 marks on the typical paper 4 question.
To question 8. So bag A contains 5 black balls and 2 white balls. Bag B contains 4 black balls and 5 white balls, as in the diagram. Gustav, I always like their names, picks 1 ball at random from bag A and replaces it, so that's very, very important when we're looking at these kind of questions. Write down the probability that the ball Gustav picks is black. Well, if we look at bag A, we've got 1, 2, 3, 4, 5 black balls, and there are 1, 2, 3, 4, 5, 6, 7 balls in total. So we get our answer of 5 over 7, like so. And Sharia picks 1 ball at random from bag A, notes its colour and places it in bag B. Interesting. And then picks a ball at random from bag B. So I think this is a 2-part question. Both balls are white and then 1 of each, I think. Yeah, exactly. So if I was to do a question like this, I would certainly draw a tree diagram. It will make your life a lot easier for just working out the answers that we need. So I'm going to put in black and white, BW. You could also use B and B dash if you so wish. And we're just going to draw a quick tree diagram. It doesn't have to be the neatest thing in the world, but you do need to have that there. So let's go through. Pick a black ball. Well, we've already done that part, so that's 5/7. And probabilities always have to add up to 1, so this needs then to be 2/7. Helps if I can add 5 plus 2 is 7. There we are. I'm kind of thinking ahead to the next part of the question. So, the probability of a black ball from bag A, 5/7, and the probability of a white ball is 2/7. Now he takes that black ball, or she takes that black ball at this point, and puts it in bag B. So imagine we're going along this branch here, and I put an extra black ball. I should probably do that in black. Make it a little bit easier. So I put a black ball into bag B, and now we take a ball out at random from bag B. So notice now we've actually got 1, 2, 3, 4, 5 black balls out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 5 tenths for black, and again these always have to add up to 1, so then we get 5 tenths there like so. Okay, and then at this point what we do is we imagine we go back to the beginning. So I'm going back to the beginning of my situation. Now I put in a white ball. So I indicate that by a circle like this. And we go through the same logical process. So we count how many black balls. We now got 1, 2, 3, 4. So we've got 4. How many in total? We've got 10 like before. Notice these fractions will always have the same denominator. And this will then be equal to 6/10. Once you've got your diagram, it makes your life a lot easier to work out the next two parts of the question. So the probability that both balls are white, we're going to work out probability of white is we just multiply these two fractions together. Multiply along the branches. So we get 2/7 multiplied by 6/10, which gives us 12/70. Now, I've said in previous videos that I don't really mind if you don't simplify. The same thing here, but I am going to simplify this down to 6/35. Although strictly speaking, this is not necessary, but try and get into good habits. So this is going to be 6/35. Notice for the next question, one ball is black and the other ball is white. I've done a lot of the hard work here, okay? And it doesn't matter what order this is in, as far as I can tell. So one ball is black and the other ball is white. So we're looking for the probability of white-black and the probability of black-white, and then we take each probability and add them together. So let's work this out. Probability of white-black, well, it's going to be going along this route. So we've got 4/10 times 2/7. Should do it the other way around, really. Put this in brackets. White-black, and then we do black-white. So we get 5/7 times 5/10. Again, I'm not going to reach my calculator, but you could at this point. We times fractions here. 4 times 2 is 8. 10 times 7 is 70. 5 times 5 is 25. 7 times 10 is 70. Notice we've got the same denominator. That's very, very helpful. If we add those together, 25 plus 8 is 33/70, which cannot be simplified. So we will leave this as 33/70. All good. Draw your tree diagrams. Okay, so now we're going on beyond the standard questions, and now they'll try and change the context slightly for this. So the balls are returned to their original bag. So if I go back to my original diagram, I would do this in the exam to remind me. I would wipe out anything I've done so far. Okay. Gene picks a ball at random from bag A. He then replaces the ball. Let's underline that. He continues to do so until he gets a white ball. Find the probability that the first time he gets a white ball is on the 5th pick. So basically what's going to happen here is you're going to pick 4 black in a row, yeah? Before then you get to pick the white ball on the 5th pick. Okay, so we need to work out that probability. So, and then we get white afterwards, of course. So we're going to go through this one at a time. does replace the ball, so that's important. So we've got 5 over 7. Then he tries to pick another black ball, so this is our second time. The probability hasn't changed because the ball goes back. This is our third time. This is our fourth time. And now on the fifth go, we'll now choose a white ball. Notice no balls have been removed from the bag, so we've now got 2 out of 7. So we have a very, very long fraction to work out, which I am going to do on my calculator. Okay, we're not doing this, we're doing this. Okay, so let me get my GDC out. So control, divide for the fraction, 5 over 7 times, this is going to take patience, so control, 5 over 7. And the key thing here is just not to make a mistake. 5 over 7. We've now got to our fourth try. 5 over 7. Weird question, I haven't seen a question like this on IGCSE. And then 2 over 7. We get some horrible big fraction. There we are. 1,250 over 16,807. Again, 2-mark question. So I'd write that working I've just written and then write the answer. So 1,250 over 16,807. Okay, key thing is just I'd write your logic here. So 4 black in a row and then a white. Okay, because otherwise the white's already picked. The balls are returned to their original bags. Leanne picks a ball at random from bag B. She continues to do this without replacement until she gets a white ball. The probability that she picks the first white ball in her nth attempt is this fraction here, 5 over 126. Find the value of n. I think I would do this by a trial and error procedure. Now notice we've got without replacement, so we need to be a bit careful. So we need to work out the black ball. So we go back. The probability of getting a black ball here is 4 out of 9. Okay, now obviously that's not 5 over 26. So then we get times. Now we've chosen a black ball at this point, so we're going to choose another black ball. So that's going to be 3 over 8. Now what I would do is actually check this. So this is equal to 12 over 72. Which I think we can see is not the same as this fraction. This is far too big. Yeah, so this is too big. I think I take this in a trial error, and then I'll just keep going. So 4/9 times 3/8 times 2/7. Multiply those together, we get 24 over, okay, 9 times 8 times 7. That gives you 504. Now, is that the same fraction? I think on site you can see this. You can also write this as 1 over 21. And I think we can see here these are not the same. So that's fine. But now we want to work out, okay, then we take this and then times it by the white ball. So say we've got 3 black in a row, we would then need to times by the probability of getting a white ball at this point. So at this point, we've then got 6 balls in the bag, and 1, 2, 3, 4, 5 of them are white. So if we do 1/21 times 5, 6, that does give us the fraction that we want, 5 over 126. So the way this works is it'll be 3 black balls, then there's 1 white ball, so it'll be the 4th attempt, so n is equal to 4, where this actually occurs. Now you could check this after 2, so you could do 4 over 9 times 3 over 8 times then 5 over 7, because there are 5 white balls and 7 balls in total. If you work this out, you get 60 over 504, and we can pretty straightforwardly see this is not the same as 5 over 126. So it can't be n is equal to 3. So I've just done this by a trial and error method, and then that gives us the answer of n equals 4. I think that's probably the most straightforward way to go about this. Okay, quick look at the mark scheme so you can have a look through. Just make sure you understand the OE, which is or equivalent. I think, if I remember rightly, this is you can't just write down the number 4. You have to show corresponding working to that as well. This question was generally well answered by students. So you can see the majority were okay. The thing with part D is there's no standard method. All you need to do there is make sure you're happy with a trial and error method, and then you get to the right answer. So it's not as if you need to learn anything off by heart in order to answer that question. So we have a probability question. Trisha's got 2 bags. In the first bag, we have 6 white balls, 4 red balls. In the second bag, 4 blue balls, 3 white and 2 red. She takes a ball out at random out of the first bag, then takes a ball at random out of the second bag. So there is no replacement. It is with replacement, i.e. there's no change in probability between bags 1 and 2. So it stays as is. And we need to complete the tree diagram for 2 marks. So if we take our first bag, the number of white balls, there are 6. And we have 10 balls in this bag in total. So this will be 6 out of 10. And then for the probability of red, there will be 4 red balls out of 10 as well. Now we have a completely different bag. So for the second bag, there are 4 blue balls. So it'll be 4. And then how many balls are there in this bag? Well, let's be careful. 4 plus 3 plus 2 is equal to 9. So we get 4 out of 9. Likewise, for white, we have 3 out of 9. And then for red, we have 2 out of 9. And notice it'll be the same regardless of whether we chose white or red beforehand. It will still be the same probabilities. So 4 out of 9, we have 3 out of 9, and finally here 2 out of 9. Nice for 2 marks. Certainly that's marks you should be picking up in this paper for exam. Now they ask you some probability questions linked to this. So first of all, we want to work out the probability that Trisha's 2 balls are both white. So let's go back. So we want the probability of white, the way I tend to write it. And the way we do this is we take the probability of the first one being white, that's 6 over 10. And then we multiply along the branches. So we multiply this by 3 over 9. And remember, to multiply fractions, we times the top. So 6 times 3 is 18. And then 10 times 9 is equal to 90. And we should simplify at the end if we can. I'll leave this there for a future calculation. Generally speaking, on IGCSE Cambridge, they don't mind if you leave it like this. But we should try and simplify it. And if we divide top and bottom by 9, we get then 2 out of 10. Bottom should be 10 and not 9 because we're dividing by 9, top and bottoms. Just to show you what we did there, we divide by 9 here and we divide by 9 here. And then we get to our answer of 1 over 5. But I'll just show you the mark scheme here quickly. So notice if you leave it as 18 over 90 on this exam, or OE or equivalent, that's absolutely fine. You get your 1 method mark for 6/10 times 3/9. That's wrong. It should be 9 here, not 10. So a mistake in the mark scheme, but that's fine. We know what we're doing. 18 out of 90. So we need to write that. So writing the working, 6 over 10 times 3 over 9. That gives you 18 over 90. Notice that's all I need to write. Now for this one, we need to be slightly careful. We need 1 white and 1 red. So that can be either way round. This is important. So we want the probability of red, white, plus the probability of probability of white, red. There we are. Let's not get those mixed up. So let's go back. So the probability of white, red. So let's do this one first. Well, that's going to be 6/10 times 2/9. Notice I'm not going to simplify at this point, so 12 over 90. And then we work out the probability of red-white. So red-white, no weds, just reds. So we get 4/10 times 3 over 9. There we go. And we also get 12 over 90. And so we want to use these two answers here. I mean, I would usually write this working on the other page, but I'm working between two slides. So our answer is 12 over 90 plus 12 over 90 is equal to 24 over 90. Now I know with the mark scheme I can leave it like this. Kind of different to what they teach you in year 7, 8 and 9. You always simplify whenever you get the opportunity. Tree diagrams is one of the few exceptions to that. So we get 24 over 90. Biggest mistake made on this question is you don't take into account both ways round. So you need to do white, red and red, white. I'll quickly show you the mark scheme here. Okay, so 24 over 90 is fine. Now part 3, we want to make this as easy as possible for us. So we want to work out the probability that they're different colours. So notice you can either have two balls that are different colours or the same colour. Okay, it's one or the other. And all probabilities have to add up to 1. So a quicker way of doing this question, rather than working out everything individually, is doing 1 minus the probability of the same colour. Because whatever we're left with after we work out the probability of same colour is that it must be different colours. The reason I do it this way is that we've already worked out some of these things. So we've already worked out the probability of both white, which is 18 over 90. So all we now need to do is work out the probability of red, red and blue, blue, I think the other colour was. Yeah, blue, blue, exactly. And then we can just work it out from there. So what I'm going to do is just work out the same colour. In fact, it's even easier than that because we only have blue in the second ball, not the first ball. So all we need to do then is actually work out the probability of red, red, which if we times these two fractions together, we get 8 out of 90. And that's the only way we can get two of the same colour, probability of white, white or red, red. Okay, so I'm going to bring that over, this answer here, minus 8 over 90. Now, remember, 1 on its own is 90 out of 90. This is why I did not simplify to make the subtracting fractions much easier. And then if I do this calculation, well, 90 minus 18, well, that's going to be equal to 72. 72 minus 8, well, that's going to be equal to 64 over 90, yeah? Which, as we saw in the previous mark scheme, does not need to be simplified. So I'm going to leave it as 64 over 90. And there's our answer there. So one thing I want to mention with this question is don't always think you have to do things in always the same way. Look for opportunities to save yourself time. And this is a good opportunity. Think, of different colours. Well, if I work out probability of things being the same colour and do 1 minus that, I will get the answer much, much more quickly. Okay, and you'll see the actual exams report actually mentions this. So the probability of different colours was a little more challenging, but well answered by many candidates because they took this longer method of working out white, red, red, white, red, blue, blue, red, blue, white, white, blue, and added them all together. Whereas if you use the more efficient method, like I've just mentioned here, you'll find that's much, much more quick. Okay, so particularly in an exam which is 2 hours, 15 minutes long, you want to look for ways to make your calculations more efficient, and this is one possible way. But notice this question is generally well answered, so you need to be getting all the marks here to make sure you're heading for those top grades.
So, if you're looking for a bit more practice to help you with your IGCSE course, then please check out the 2 videos just here. They're really, really useful in getting you up to scratch so you're ready for those IGCSE exams.